Find the solution of the differential equations. So we got a differential equation that satisfies the given initial condition, and we also have an initial condition to determine the value of constant c. These are called initial value problems. These problems, in short, these are called initial value problems, in short, IVPs. So let me do part 1. So here we got a differential equation and an initial condition. So this differential equation is same as when we separate the variables, we can pretty much writing in terms of differentials. So we can just write dy equals just moving like dx. It's kind of cross multiplying. It's not happening, we cannot cross multiply, but when we write in terms of differentials, this is how we write. Now we integrate both sides, because y in the left side and all the x's on the right side. There is 1, antiderivative of 1 is just y, and 4x is 2x squared plus some constant. So y in terms of x is given in this way. So this y is in fact in terms of x. Okay, now we need to determine the value of c using this initial condition. So y is 5 when x is 1. So using y at 5, so y is 5, so this y value is 5 when x is 1. So 1 is squared. 2 times 1 is squared, just 2 plus c. Subtract 2 from both sides, we get c is 3. Now back substitute here and we have the solution y. So y equals 2x squared plus c is 3. Okay, let's do here on the right side. So this one, writing in terms of differentials, so dy secant square y, we can write in this way, secant square y dy equals dx. Now we separated the variables, we can integrate both sides. Of secant square y, we know that derivative of tangent x is secant square x. That means antiderivative of secant square is tangent. Tangent, the variable is y. Here is 1, here is 1, so antiderivative of 1 is just x and plus c. Now let's find the value of constant c first, then we can isolate y. So here is the initial value. So using y at 2 equals 0, y is 0 when x is 2. So tangent 0 equals 2 plus c. And we know that tangent of 0, radians is just 0. 2 plus c. Subtract 2 from both sides, we get c equals negative 2. Now let's go back and plug in here. Then we're gonna get tangent y equals x minus 2. And we can isolate y, taking tangent inverse both sides. Y equals tangent inverse of x minus 2. And in fact there is a restriction on y when we write tangent inverse, but for this label I'm just gonna say this is the final answer, not gonna put anything else. So here is the third problem. So we can separate the variables doing kind of cross multiplying here. In fact that is writing in terms of differentials. So y dy equals x squared dx. We separated the variables. Now we can integrate both sides. and that gives us antiderivative of y is y square over 2. This is x 3 over 3 plus c. Now we can use y at 0 equals 2 first, determine c, then solve for y, or we can solve for y first, then find the value of c later, same thing. So using the initial condition y at 0 equals 2, so y is 2 when x is 0. So 2 is squared, 4 over 2 is 2, x is 0 plus c, that means c is 2. Now substitute here, we're gonna get y square over 2 equals x cube over 3 plus 2. Now we need to isolate y, so get rid of 2, for we can multiply both sides by 2. Okay, when we do that, then we have y square equals 2/3 x cube plus 4, and now we take square root of both sides, so y equals square root of 2/3 x cube plus 4. As we know, it could be plus or minus, not both, plus or minus. In this case, if we look at this initial condition closely, okay, that was in the question here, y at 0 is positive 2. When we plug in x equals 0, we should get y as plus 2. So when we plug in 0 here, we should get plus 2. So this minus is invalid. So this should be just plus, or for plus, we don't have to write. So this should be plus, not plus or minus in this case. Okay, if we had negative 2 here in the initial condition, I think the work would be the same, but plus or minus, we had to keep minus sign. Okay, this is final now. And the fourth question is here. So this is the ODE, ordinary differential equation. So we need to separate the variables, means function of y dy in the left, function of x dx in the right side. So here is x times y squared. Let's divide both sides by x. So I'm moving x's on the right side. That leaves y squared dy over dx equals, we are dividing both sides by x. So x plus 1 over x. Then now we need to move dx to the other side. So writing this in terms of differentials, y squared dy is this junk dx, x plus 1 over x dx. Now we separated the variables, function of y dy, function of x dx. Now we integrate both sides. So in the left it's easy. So antiderivative of y square is just y 3 over 3 from the power rule. Y 3 over 3 equals, here we got a fraction, and since we have two terms in the top and only one, we can separate into two fractions and get rid of the fraction. So this one, let me write just here, this is pretty much x over x is 1 plus 1 over x. So the integrand here is just 1 plus 1 over x. Now we are integrating this. So antiderivative of 1 with respect to x is just x, plus antiderivative of 1 over x is natural log of absolute x. But in this question, if we look at closely, y8, this is x value, this is y value. Y is 3 when x is 1. So x is already positive. So we don't have to put absolute x. Okay, but you can always put, it doesn't matter. At the end of the day, we will write this down, but just positive is fine. So x is positive in this case because of this initial condition, so absolute value is not necessary. Okay, but if you are not sure, you can always keep absolute value plus c. Now let's use this initial condition to determine the value of c. So using y at 1 equals 3. So y is 3 when x is 1. So 3 cubed 27 divided by 3 is 9. X is 1. ln of 1 is 0. Natural log of 1 is 0 plus c. Subtract 1 from both sides. We get c equals 8. Now back substitute here. So y 3 over 3 equals x plus natural log of x plus 8. Now we need to solve for y. So multiply both sides by 3 just to get rid of this fraction. Then we get y3 equals 3x plus 3 natural log of x plus 24. Now to get rid of this cube, we just take cube root of both sides. And there is no plus minus in cube root, by the way. 3x plus 3 ln x plus 24. Final.